In this video, we're going to take a look at an introduction to solving quadratic inequalities. And before we take a look here at solving any quadratic inequalities, we're going to start with a quadratic equation. Let's say we have here y equals, and we have x squared plus 7x plus 12. Now, if y is equal to 0 here, what would we get? Well, we'd get x squared plus 7x plus 12 is equal to 0. Okay? And what I want to do here now is solve this quadratic equation. So we want to solve this here. Now, there's a few different ways that you can use to solve this quadratic equation here, but the easiest and fastest way would be to factorize. If I factorize this quadratic here, I get x plus 4 in one bracket, and in my other bracket here, I get x plus 3. Okay, and that's all equal to 0. So from here, we can easily identify now these solutions. I get x equals minus 4. I'd also get x equals minus 3. Okay, so these solutions are also known as the critical values. Now we don't have to, but what I am also going to do here is draw a quick sketch of this quadratic. If I draw a sketch here of this quadratic, don't have to be perfect, but just so we can kind of see the quadratic that we're working with here. That's my y-axis. This is my x-axis here. Then from our critical values here, we know this quadratic here crosses the x-axis at minus 4 and minus 3. So let's say this is minus 4 here, and this is minus 3. It'll look, say, something like this. Okay, and it'll keep going, and it will intersect here with the y-axis at positive 12. But if I just draw that as a sketch then, we can see our quadratic now, and it intersects here at minus 4 and minus 3. Okay, so if we were solving this quadratic equation here, then that would be the question complete. We found our two solutions, question done. Now for a quadratic inequality here, there's a bit more work involved. So the reason why we've gone through an equation first is because the way that we solve a quadratic inequality is almost identical to solving a quadratic equation. So now let me just change my pen color here. Let's do this in blue. So now what we're going to do here is solve a quadratic inequality. So I've got x squared plus 7x plus 12 is strictly less than 0. It's quite a dark shade. I think it might almost be a purple. So let me change that to a slightly lighter shade here. So x squared plus 7x plus 12 is strictly less than 0. So how would we solve now this quadratic inequality? Well, we start with the exact same method here of factorizing. If I factorize this quadratic here, it's the exact same as this one. So obviously we'll get the same factorization. I'm going to get x plus 4 times x plus 3. And that will be strictly less than 0. Okay. So from here, again, we identify the critical values. And again, they'll be the exact same. So I'm going to get x equals minus 4. And x equals minus 3. Okay. So that's the critical values there. Now, for a quadratic equation, that would be the question complete. But that isn't the case for a quadratic inequality. We need to keep going. And the next step that we do here now is we draw a sketch of the quadratic, which we've already got here. So we don't need to do it again, but that would be the next step here. So from our sketch now, we need to identify the region here that satisfies this inequality, or the values here that satisfy this inequality. And in this case here, because we're looking for less than 0, so in other words, where is it below the x-axis, that would be between minus 4 and minus 3. That'll be this shaded blue region here, or this blue region here underneath the x-axis. This is my x-axis here. So the way that we present the solution here then is as a strict inequality, because my original inequality here is strict. And we are between minus 4 and minus 3. Okay. And there we have it. So that would be our solution there to that quadratic inequality. And now let's consider, again, do this in a different color. What happens now when we are greater than or equal to 0. So solve x squared plus 7x plus 12 is greater than or equal to 0. So in this case, again, the first step is the exact same. We start by factorizing like this. Again, we'll get the exact same. I get x plus 4 times x plus 3. And that would be greater than or equal to 0. Again, we identify the critical values here. And obviously, they will just be the exact same again. So pretty standard at this point. So I get x equals minus 4. And x equals minus 3. And again, what I do now is I draw a sketch of the quadratic, which we've already got here, so we don't need to worry about that. But if you didn't have it, you do need to draw a sketch. So from here now, we just need to identify the correct regions here that satisfy this quadratic inequality. And in this case here then, we're going to have two regions here. I'm going to have everything to the right of minus 3 here, like so. I'm going to have everything to the left of minus 4. Okay. So how do we present those now as our solution to this quadratic inequality? Well, in this case, then we say that x, if we're to the left of minus 4, that is values smaller than minus 4. But because this here includes, so it's greater than or equal to 0, we also need to include that inequality symbol. So it's going to be x is greater than, sorry, I should say less than. So x is less than or equal to minus 4. So for example, minus 5, minus 6, those values are getting smaller. And then for minus 3 here, we're looking for values greater than minus 3. So minus 2, minus 1, 0, 1, 2, 3, and so on. So in that case, then x is greater than or equal to minus 3. Okay. And there we have it. So that gives us the solution there to that example. And that gives everything that we need there then for our introduction to solving quadratic inequalities. What we'll do now is just take a look at some practice questions here for solving quadratic inequalities. Taking a look here then at the first question, we're asked to solve x squared plus 4x minus 5 is strictly less than 0. So remember, the first step here is to factorize this quadratic. If I factorize this quadratic here, nice and straightforward, I'm going to get x plus 5. Get x plus 5 times x minus 1. This will be strictly less than 0, like so. Now from here, we can identify the two critical values. In this case, we get x equals minus 5. And from this bracket here, we get x equals positive 1. Like so. So the next step here now is to draw a quick sketch of this quadratic. So I quickly draw a sketch here. If I say this is minus 5 and this is 1 here, then we'll get something that looks, say, like this. Okay. So we're now looking for where this is strictly less than 0. So in other words, where is this below the x-axis? So if I do this in a different color here, let's do it in orange. So where is this below the x-axis? Well, that would be between these 2 points here. Okay, so this shaded orange region here. So presenting the solution here as an inequality as well, we say now that x is strictly between minus 5 and positive 1. So therefore, we are between minus 5 and 1. Okay. And there we have it. So that's the solution there to the first question. If we just take a look now at one more example here to finish with, we're asked to solve x squared minus 9x plus 14 is greater than or equal to 0. So as always, we start by factorizing here. So we'll get double brackets like so. These will be greater than or equal to 0. If you factorize this correctly here, what you should get is x minus 7 and x minus 2. Okay. So from here, we now need to identify the critical values. So we'll get x equals 7 and x equals 2. So once we have the critical values here, we now need to draw a sketch of this quadratic here. So as always, don't need to be perfect. It's my y-axis. And we've got 2 and 7 here, so it's my x-axis there. Let's say this is 2 here, and this is 7. we'll get something that looks, say, like this. Okay, so now we're looking for where this is above the x-axis because it's greater than or equal to 0. So we use a different colour here to highlight this solution. Do it in orange. So where is this above the x-axis here? Well, we have two regions. We have everything to the left of positive 2 here, like so, and everything to the right of 7. Okay, so then presenting the solution here, we want everything that is less than or equal to 2. So x is less than or equal to 2. This is our solution here. So therefore x is less than or equal to 2. And x is greater than or equal to 7. Okay. And there we have it. So that gives the solution there. So the very last example, our question 2. That brings the end of this video on an introduction to solving quadratic inequalities.